Okay, so in this problem, we want to verify the trig identity cotangent of x minus tangent of x is equal to 2 cosine squared x minus 1, all divided by sine x times cosine x. And normally we would start with the more complicated side, and visually it looks like this is more complicated than the subtraction, but I think changing these to quotient identities, we would have two fractions being subtracted rather than just one fraction. So I'm going to consider this left-hand side the more complicated side and start with that as my given information. So this will be my given, and this is the side that I want to try to make it match. So I'm going to start by changing everything into sines and cosines using quotient identities. So cotangent can be rewritten as the ratio of the cosine of x divided by the sine of x. And then tangent as a quotient is sine of x divided by the cosine of x. So that second step was using a quotient identity for cotangent and for tangent. And that got us all into sines and cosines. Now in my next step, I'm going to find a least common denominator, and I need that LCD to be sine x, cosine x. So this first fraction, I'm going to multiply the numerator and denominator by cosine of x. And then the second fraction, I'm going to multiply the numerator and the denominator by sine of x. So in step 3, that will give me cosine times cosine is cosine squared x, and then minus in the middle because I'm subtracting, and then second fraction sine x times sine x in the numerator, that's sine squared x. Okay, then that's all over my common denominator, which is sine x cosine x. And that was finding a least common denominator and subtract the fractions. Okay, for step 3. Now, when I compare what I have here to what I'm trying to get to, it looks like now I've got my denominators already matching. That's perfect. The numerator, I've got one of these cosine squared x terms. I needed to have two of them and then a minus 1. So I don't want to mess with anything here. I want to keep the denominator the same and that cosine squared x term the same. Instead, I want to see what I can do with this negative sine squared x and see if I can't swap that out. And to do that, I'm going to remember that there's a Pythagorean identity that says that sine squared x plus cosine squared x equals 1. So if I solve this for sine x, I would subtract cosine squared to the other side, and sine squared x would be equal to 1 minus cosine squared x. So I'm going to use that form of the Pythagorean identity to swap out this sine squared x in my verification here. So I'm going to leave the cosine squared x alone. I'm going to leave that denominator, sine x, cosine x, all alone. And now here, instead of sine squared x, I'm going to go ahead and replace that with this Pythagorean identity, 1 minus cosine squared x. And that is using a Pythagorean identity in line 4. Okay, so next, to simplify, I'm going to distribute this negative over the parentheses to the 1 and to the negative cosine squared x. And so I'll have a cosine squared x minus 1, and then a negative times a negative is a plus cosine squared x, all divided by sine of x cosine of x. And that was simplifying using the distributive property. And now we're going to simplify in our last step here. And we'll do that by combining like terms in the numerator. So cosine squared x plus another cosine squared x is 2 cosine squared x. Then our minus 1 in the numerator, and that's all divided by sine of x cosine x in the denominator. And that now matches what we had set out to accomplish, and our identity is verified. So we have just shown that cotangent of x minus tangent of x, that does in fact equal 2 cosine squared x minus 1 all divided by the quantity sine x times cosine x.